Hello everybody, and we're going to take a look here at video 11 for limits and derivatives unit. We're going to be talking about the second derivative and acceleration. Alright, so I'm going to do numbers 1 and 3 with you, and then I'm going to leave for you to try numbers 2 and 4. So the second derivative, when using the power rule, we just apply the power rule twice. So I'm going to start by finding the first derivative and making sure that I'm labeling my answers as the first derivative, and then I'll show you the notation for the second derivative. So I have 7x to the 6th minus 35x to the 4th plus 6x squared plus 15. I'm going to repeat the power rule here, and that's going to give me my second derivative, which I will denote by y to the double prime. That's not an 11, and you cannot write a 2. We write it as double prime. Kind of looks like apostrophes. So now I'm going to use the power rule. So 42x to the 5th minus 4 times 35 is 140 x cubed plus 12x. All right, number 3. Before I can do this, I have to prep my my rational expression here by subtracting the exponents. So I'm going to subtract these to get 3x to the 4th, and then plus, and I'll subtract the 8 and a 1 to give me x to the 7th. Now I'm going to use the power rule to find the first derivative, and I get 12x cubed plus 7x to the 6th. I'll do the second derivative now, because that's what the directions are asking me, and I'll get 36x squared plus 42x to the 5th. Okay, so be careful when you try number 2. You have a negative exponent along with a fraction. You're subtracting 1 when you're doing the power rule. And number 4, before you can get started, you're going to have to multiply out those binomials. So there's just some hints so you can get working on those. All right, so here's an application, acceleration. We've done velocity before, so let's take a look at this one. So we're going to find the position at 1.5 seconds. I've got here s of t, and s of t is my position function, and I would like to find s of 1.5. So I'm merely going to my calculator and substituting in 1.5 seconds into every t value for my original function here. And when you do that, go ahead and take a second to calculate it. I get 65.75 feet. Part B, to find the velocity at t equals 1.5 seconds, I have to first find the velocity function. The velocity function is the first derivative. So I take the first derivative and I get negative 6t plus 15. Now, I'm going to substitute in v of 1.5 into this function. I'll plug that into my calculator and I will get 6 feet per second. That's the label for our velocity. The next one is my second derivative, which means I'm taking the derivative of t, and that gives me my acceleration function, which is just negative 6. Now when I look at this and I say, oh, well, I have to plug in a of 1.5. Well, there is nowhere to put the negative, or put the 1.5, because all I have is a negative 6. Now this statement right here says I have a constant acceleration. Well, if it's constantly negative 6, then it doesn't matter what time I'm evaluating. I could be looking at 35 seconds or 4 seconds or 7.5 seconds. It doesn't matter. My constant acceleration says it will always be negative 6, and we label this with feet per second squared. And I know there's probably other people that have had physics that might label that a little bit differently, but we always have our time squared. All right, so number 6 is very much like that. You can give that a try on your own. And then we're going to try lastly together here number 7. Number 7 is worded a little bit differently because at each of these I'm asking when is it equal to 0. So I'm going to start by taking my position function, negative 16t squared plus 4t plus 30, and I can attempt to factor this, or I can go ahead and use the quadratic formula. I know it's a quadratic formula will always work for me, so I'm going to go ahead and try that. That's negative 4 plus or minus the square root of 4 squared minus 4 times negative 16 times 30 all over negative, or 2 times negative 16. When I start to simplify that, I get negative 4 plus or minus the square root of 1936 all over negative 32, which then simplifies to negative 4 plus or minus 44 divided by negative 32. My 1936 was a perfect square. When I come up with something that has no radicals, I actually know that I could have factored this, but maybe the quadratic formula would have gotten me to the answer a little bit faster because I don't have to do any guess and check or remember any methods. I just have to remember the quadratic formula. So from this, I'm going to get negative 4 plus 44 divided by negative 32, and negative 4 minus 44 divided by negative 32. When I enter the first one into the calculator, I realize it actually gives me a negative time value, and I'm not interested in negative time. It doesn't exist. So the second one, negative 4 minus 44 divided by negative 32, will give me 1.5 seconds. So that's when the position is equal to 0. At what time is the velocity equal to 0? Well, if I want my velocity equal to 0, I have to first find the velocity function. So I have negative 32t plus 4. I'm going to take this negative 32t plus 4 and set it equal to 0 because it asks me when is it equal to 0. Subtract 4, divide by negative 32, and I come up with, for part B, the time equals 1.25 seconds, or 1/8 of a second. So very quickly, is the velocity going to be equal to 0? Next question, at what time is the acceleration equal to 0? So I need to find my acceleration function, which is taking the derivative of my velocity, or the second derivative of the original, and I get negative 32. Again, this says that I have a constant acceleration, and my constant acceleration means it's constantly negative 32. So to answer the question, when is the acceleration equal to 0, I can proudly say it's never equal to 0 because it's constantly negative 32. So the answer to part C is never. Okay, so I'm going to leave with you to try on numbers 2, 4, 6, and 8, and we can bring any questions that you have to class.